Thank you so much for watching the Weaviate Podcast. I'm super excited to welcome Andriy Mulyar from Nomic AI. And quickly before diving in, this is Christmas come early for people working with Weaviate and vector embeddings. Nomic's Atlas visualization of embeddings is just amazing. It's so cool to see these clusters, and we have an integration with Weaviate to show. But even before talking about that, huge congratulations to Nomic AI on raising a $17 million Series A. You can see it in the press release announcement, Atlas, GPT4All, all these amazing technologies. So firstly, before even getting into any of the technical stuff, huge congratulations to everyone at Nomic AI. This is just amazing to see, and I'm so excited about how this space is developing. So let's get into that a little more about what this means to space developing. So maybe you've seen this kind of thing before. This is topic modeling. We've had past podcasts with, say, Martin Grutendorf's from BERT topic, trying to understand how this kind of stuff integrates with Weaviate. But so what you have is, you take all your documents and you embed them, say with OpenAI embeddings that are 1536 dimensions, and then you project that into a lower dimensional space with, say, TSNE, UMAP, and so on, and then you visualize the lower dimensional space, and then you cluster, and so then you could cluster the two-dimensional points, or you come up with these topic labels for these different kind of labels. So you see, if you zoom in, these are the point cloud segmentation. These are embeddings for all the papers published in NeurIPS from 1987 to 2022. So these kind of maps are so interesting. And so here's this tutorial on how to get your data from Weaviate to Nomic Atlas for this visualization, flowing the vectors from Weaviate to Nomic, all the super exciting stuff. Personally, I've added this to my Weaviate podcast search demo to play around with it. This is like my dog food I use to see what all these things look like. And so what you see is, you can take your data out of Weaviate, put it into this space, and hopefully that's a good visualization. Sorry, so let me just increase the point size so maybe it's a little clearer, but you can see how each of these podcast clips, you can see the topics, click clustering and topic modeling, podcast clips where we're talking about clustering and topic modeling. But anyway, so this was so much fun to play with my own data, and I hope you enjoy seeing your data like this. I think we'll get into it on the podcast, but I think this is one of the most exciting ways to understand the quality of your embedding spaces. It's one way to compare embedding models is to see the latent spaces produced by them, and whether these topics make sense, whether you agree with the clusters and so on. So without going into it too much further, I'm so excited to present this podcast with Andriy. This was such an exciting one. Hey everyone, thank you so much for watching the Weaviate Podcast. I'm super excited to welcome Andriy Mulyar. Andriy is the founder of Nomic AI. Nomic is doing so many exciting things. For one example, they have done this embedding visualization directly in the browser at 10 million scale and beyond. It's so exciting to see. Andriy is also the creator of GPT4All, which is another topic that I'm sure everyone has heard about. So Andriy, I'm so excited to talk to you and learn how you think about all these topics.
Hey Connor, thanks for having me.
Awesome. So could we kick this off by diving into the founding story of Nomic, what led you down this space?
Sure, yeah. So I think every good ML story, it starts at a NeurIPS machine learning conference. So this was 2019, and this is when everyone in ML cared about images, and nobody knew that that machine learning models were just these amazing manipulators of text, even though transformers have been out for about 2 years. And I actually ended up going to this. It was a BERT meetup. So BERT was so before everyone was naming models after llamas and alpacas, it was Sesame Street characters. And there was this meetup for BERT, which was this model that Google released in 2018, which was a transformer model trained to sort of self-supervise over text, and then you can do all these magical things with text that you couldn't do before. And at that meetup, I actually met my co-founder, Brandon. So Brandon, CEO of Nomic, he was actually working at the time at this startup called Rad AI, which was, nowadays you call them generative AI startups. Back then you called them machine learning startups that did things with text. And what they were doing is basically summarizing radiology reports automatically with large neural networks. And you can imagine the kind of neural networks they were using at the time, because once transformers came out, this is when all these things became feasible. And so we sort of met up there. Brandon and I ended up working there together for about a year, and we found out all these sort of difficulties that existed in training large-scale transformer models on large quantities of text. This is way back before GPT-3 even came out. And so we took those learnings, and basically the TLDR of the learnings is that you need to look at your data. Everything in the process of training a big neural network on a lot of texts will eventually become replicable. Everything from the data ingestion all the way to the model training, the model serving. Mosaic ML, for example, is doing great things and like making training replicable. But the hardest part is always making sure you have your data curated in the right way. So that was sort of like this like clear non-replicable problem that we saw. We sort of went in different ways after the company. And Brandon went to go work at Square. I went to go start a PhD at NYU working on interpretable machine learning. And about 6 months in, basically what happened is Brandon reached out to me. He's like, "Hey, we both know this problem exists. Let's look at solving it." And sort of like the interface that we imagined for how we would have wanted at the time to go about curating large contents of unstructured text in like a replicable manner to make it faster was sort of this interface that you see in our product Atlas right now. This idea that when you're going through and exploring large collections of data, you really want the property where when you find one example of something bad or something good, you find all of the examples immediately. And this is actually a property that you only get when you're looking through data through the context, through like the lens of a neural network, through the embedding space of a neural network. And that's what Atlas was at its core. Atlas was this sort of solution to our problem that we had where we have 60 million documents of text. You need to clean them very, very quickly. You need to figure out what's in there. And that Atlas was this sort of like answer to that like overarching problem that we began developing and building on. But that's sort of like the genesis of Nomic. And we sort of started out working on that. We had sort of the MVP in beginning of spring 2022. We went out, built out sort of like what you see right now in Atlas when you go to atlas.nomic.ai, where you can go in, just drop your data sets, and you get these sort of observable sort of data maps that allow you to see tens of millions of pieces of text, images, audio, anything you can embed with a neural network all on one screen, and then be able to slice, dice, and manipulate it, just like you would manipulate, for instance, something in a pandas data frame, but you don't need to be technical to do it. So that's what you see right now.
Yeah, that's a really compelling story. I mean, there's so much stuff to that. I think, I also first became aware, like coming back to the NeurIPS conference, I think I first saw Atlas with the visualizations of the ICLR papers of clustering them and doing that kind of thing. And I thought that was so cool. That's how I first saw this whole topic modeling cluster analysis idea. But you've hit this angle that I think is so fascinating of the data visualization for curating training data for large language models, especially when you're talking about pre-training them and doing the internet scale language modeling. I think for me, I first saw this data set called the Pile, which is like 800 gigabytes, and you had like this, a nice like diagram with the squares of like how much is Wikipedia, how much is GitHub, and that was kind of like my first thing of seeing like the composition of the data sources. You mentioned Mosaic ML; they're doing a lot to educate. Here's where our data comes from, the mix of it for say MPT, and I know with Google Research, Quackly is someone I've been following for a long time, and they have a paper called Doronomy, something like that, where it's about the composition, again, like this investigation. So if we could stay on that a little more, like, so, I love what you said also about finding problems in your data set by looking at the nearest neighbors. So you take 10 million or, massive scale used to train a language model, and you embed it all into Atlas. And then you start looking at like, here is where the high loss region is, like, your model performed badly on this point, so the neighboring points tend to correlate. Is that how you're thinking about kind of how you then use this interface to improve the training data?
Yeah, so that's one way you can use it. That's actually not the way that we had envisioned in mind. It's just like a useful way of using the interface for specifically debugging, for instance, large language model fine tunes that we discovered, the thing you just mentioned, looking at like high loss regions. These sort of like initial the initial reason we sort of built out Atlas was this idea that the reason that large language models hallucinate, and we saw this when we were working at this medical AI company, right? When you're deploying a machine learning model in like a medical setting, you cannot have like a model that generates text hallucinate, right? You don't have a product. It's not a medical AI product. The model hallucinates, and the sort of core reason that hallucinations occur. And we were able to stamp this out actually while working there, is because of spurious correlations in the training data. That is, there are things in the training data that shouldn't be seen together at the model at the same time while it's training. And to be able to stamp those out, you just need to have some way of very quickly sort of like scrubbing over all of your data to figure out what's in it. But then when you find one example of something that's in it that you need to remove, you should be able to very quickly find all of those examples. labels. And this is sort of where like vector databases come into play, right? They allow you to, once you have one example, if you're looking through it through the lens of like a neural network's embeddings, you can find all of the examples instantly. And what you see with Atlas is sort of like, you can think of it as a visualizer for the vector database, like the sort of like MySQL workbench for the relational database that you see for a vector database. You can see the high dimensional embedding structure projected down into 2 dimensions while preserving the sort of properties and patterns that you see in the high dimensional embeddings. But you see those in 2 dimensions with Atlas.
Yeah, and I think if we could stay on this a little further, so I've became really interested in topic modeling. I interviewed Martin Grutendorf about BERT topic. So I like jumping ahead to the kind of this topic of like, the topic of topic modeling. How are you currently thinking about its applications?
So the way we think about it is as follows, right? Every single piece of data in the next decade will be run through some neural network, whether you have text being run through a transformer pre-trained to represent text, whether you have large language models generating piles of content to the internet that you need to somehow make sure, isn't going to ruin the world and ruin the elections, or whether it's images, audio running through all the latest, greatest neural networks that are coming out. And what you really want to be able to do is make sense of all this embedding data that exists out there. So Atlas under the hood, it's sort of built out as sort of this file system where you can just dump embeddings and then get superpowers over top of them. So one of those superpowers is visualization, like we were just talking about, that allows you to find patterns in your embeddings. Another one of these is topic modeling, like you just said. So what this allows you to do is find like homogeneous regions of your embedding space. So like once you find a cluster in your embedding space that exists, what we do is we ensure that that cluster can be representable and sort of accessed over like HTTP API calls, for example, or just like accessed out. So embeddings that are all similar together sort of get represented as sort of one topic, like you were saying. And yeah, I think I guess let me put it in the context of just like a builder, right? When we were building out Atlas, the very first thing we did is we implemented the sort of dimensionality reduction algorithm that scaled to tens of millions of embeddings, which doesn't exist. Like you take UMAP or TSNE out of the box, you're not going to be able to scale to tens of millions of embeddings. So we had to sort of implement our own. And once that was there, it was awesome. Like you could see all of these dots on a screen, and we would show it to people, and they would be like, "Wow, this is so cool. What does this mean? This makes no sense." And topic models were sort of the thing that allowed us to start educating people who were like maybe not like ML experts as to what they were looking at, because you could very, very easily get out sort of the trends that you were seeing. You would see like this cluster, it actually is homogeneous because it's all the same color, for example, on the sort of 2D map view that you see in Atlas. And then sort of like the next upgrade was like topic labels, for example. You could go in and see not only, for instance, if you had embeddings of text, you can see not only like the actual topics via the clustering that you see on the map, but you could actually see like high-level human descriptions of those of those topic labels. And so this sort of like segues also into GPT4All. I don't want to get too much in there, but you have to generate those automatically somehow, right?
Yeah, and of course we're going to talk about GPT4All, but the ability of GPT4All to maybe do like a summarization chain, as we've seen like LangChain summarization chain using the GPT-4 models, makes perfect sense that GPT4All could be plugged into that. But yeah, summarizing the topic, this kind of automatic category discovery is so fascinating. There's kind of one other idea I wanted to ask you about. I've heard this question from people, like when I'm at conferences and stuff, is they want to say, take customer reviews, dump them into this kind of thing, see the, clusters of their product reviews, and then they want to do this kind of thing of like the automatic discovery from that. I also think about maybe if there is a connection with the symbolic metadata associated with each cluster. So, you have 3 clusters, and then say it's like my tweets and I cluster my tweets, and then I say like this cluster has like, this has the most impressions, like this category of tweet, however they're embedded in the space. And so I kind of visualize my clusters with symbolic data as well. Do you think about that kind of application a lot of like, I guess like symbolic data as well for understanding what makes these clusters different from each other?
Yeah, I mean, so like at its core, what Atlas is showing you is not like black magic. It's showing you statistical properties that the underlying model that embedded the data has sort of learned. And sometimes it is the case that, for example, the metadata that you've seen humans associate, or like a platform like Twitter associate with your data, is actually already captured in the embeddings. So that's why you see, for instance, if you go on Atlas and you color by pieces of metadata, you'll see like it sort of replicates what the topics discovered, because the topics are sort of like an unsupervised way of seeing properties of that embedding space. But then if you have this metadata attached to your data, it also can be explicitly represented. And yeah, so like at its core, you should be able to just sort of discover these patterns. And we try to really be like, what's the word? Like we don't tell you how to use the platform. It's sort of your job to just use it as sort of a discovery tool. Like when you're going through and actually doing the visual discovery of what your embedding space of your data represents. And to your question, it's a little bit difficult to if you have a model that can represent your data in such a way that it's captured all the various properties that you want to make, all the various properties of your data that you'd want to use for some business purpose, then yeah, awesome. The unsupervised sort of like system that we have built out with dimensionality reduction and the topic labeling, yeah, that can automatically sort of give you access to sort of these sort of attributes. But usually, like you have some sort of like thing over top of it that you really care about. This is why, for instance, like vector databases like Weaviate, right? Metadata filtering is so important. You can't just do vector search and then you're done, right? Metadata filtering is everything. So yeah, having access to metadata is like super, super important. And the embedding space sometimes represents it, sometimes it doesn't. But you need a way of seeing it, right?
I've also been thinking about that kind of the category discovery from topic modeling to be used in filtered vector search. I guess my thing with that particular line of thinking is that if it's a property that's captured in the cluster, then the HNSW, then the graph in the vector index will already kind of capture that. So that's where I'm a little torn on that particular part of it. But I really this idea of like debugging embedding models is something I really want to get into as well. Like so like we talk about training language models with this data and visualizing the training data for language models. So is it thinking mostly around visualizing how the cluster has evolved from the latent space of the language model? Or say, are you also using this a lot for like the training of the embedding models themselves? Like maybe just to give a little more background, like my dog fooding data set with Weaviate is this podcast. I like to like take these transcriptions and put them into the vector space. And so I've been training embedding models on this particular data, and I can imagine like visualizing the clusters evolving over time, like as I add this new podcast with Andriy and then see how training on this data set changes my whole space could be really interesting. So that kind of debugging models, yeah, I'm curious how you think about that with Nomic.
Yeah, I mean, I really think that everyone should be looking at their data through the lens of embeddings. And embedding, like data changes over time, right? So embeddings will change over time. One of the things that it actually is not concretely implemented right now in sort of like a native way, but one very natural way where embeddings change over time is sort of this use case of like debugging like machine learning model trains. As a model trains, right, every time, let's say you do an evaluation on your like dev set, what happens is you generate a new set of embeddings, and it's for every single test point that you have in your data set, you get an embedding of that test point out. And the organization of those embeddings is basically a proxy for how the neural network is organizing your data. And the embedding space sort of gives you a human way, a sort of a human interpretable lens at looking at what your model is learning and what your model is not learning. We have this like really nice demo example on MNIST, where you can go in and like a PyTorch Lightning hook with Atlas hooked in to train your model. And at every single epoch, you'll sample like a view of the embedding space, and you can very much see like the digits form over time. That reflects in like the quantitative metrics, like the sort of like accuracy that you see over those 10 digits. But you can really see like as the model trains, the embedding space sort of like molds like Play-Doh. And like the 8s and the 0s are closer together than the 8s and the 7s because, well, the embeddings for those are putting them apart. There's more data points where 8s and 0s are being sort of like confounded together, causing like errors in your actual quantitative metrics. But you can see this all visually, so it's a good debugging tool for model trains as well.
Yeah, that's so compelling. I think I've seen an animation of that before, of the latent space evolving on MNIST, probably from Atlas. I saw that. That is so cool. And okay, so I really want to come back to this kind of topic modeling and property discovery topic later on in the podcast. But for now, I think we have to dive into GPT4All. You've hit the grand slam home run in AI of creating the model that everyone's talking about. How's your experience with this one?
Yeah. So It was really cool. I'm not gonna lie. It was fun. Like usually when you build an ML model, you rent like at least like when I was doing like more research work as part of my day to day. You build an ML model, you spend multiple months building it, and what happens is you go in and you write this big paper and you like release it out, and then you hear like chirps about it, and like this is like even before like everyone was like basically publishing their research on Twitter, which is like its own discussion. You would not get any feedback about it. It was really cool to sort of work with the team to get a model out that everyone really cared about. But I think GPT4All is not really about like, hey, there's this cool model and like everyone should use it and try it. Because like the model itself, it's worse than, for instance, like what you would get with a large language model API if you use like Anthropic or OpenAI. But that's not sort of like the key ingredient. The key ingredient is you can own your actual model. The model runs locally, and not only does it run locally, you don't need some accelerated hardware like an NVIDIA chip. You can run it on your CPU. So that was kind of the whole premise of GPT4All, to sort of do a demonstration that with the current set of ingredients that emerged in sort of the technology stack, so like the work of like Gurganov and on Llama.cpp, the work at Meta, sort of like accidentally releasing out these llama models that everyone wasn't supposed to have access to, but somehow everyone found the torrents for. And like all these ingredients had come together to really demonstrate that large language models aren't these like big black boxes that exist behind the APIs of cloud servers of a few big players. You can really run them locally on your machines. That was sort of the thesis of GPT4All. Do a demonstration of this. And then it turns out everyone really cared about it. So we were like, hey, we should maybe spend some more time on this.
Yo, I think you just hit the pinata with so many things. I mean, like, first of all, it was pretty fast after the release and then the public reaction to ChatGPT that you got this out. I mean, this must have been like 3 months later maximum. So it's like the speed of it is astonishing. As you mentioned, running it on the CPU with the Llama C++, that's like pretty crazy. And then it's like, I'm a little curious about, so the nature of this is you have the pre-trained checkpoint from Llama, which comes from Meta, and then you fine tune this to create GPT4All.
So that was in fact the original model. We've since sort of like the models. So if you go right to like GPT4All.io and you go in and you sort of download this UI installer that lets you play around with any of these local models. The reason you need this UI installer and you can't just like go on GitHub is because it's a lot more accessible. You basically solve all the software challenges that used to exist. Like for instance, when we first released GPT4All, what you needed to do is you needed to go in and like download this Git repository, clone it down, and then non-technical people don't know how to do that. It's not accessible. You needed to go take this random 4 gigabyte file from the internet, wait 7 minutes for it to download, and then drag it onto a directory, and then like you run some terminal commands, and that was the setup process. Now it's a little bit easier. You install this desktop client. And that's sort of like the chat UI that you see there. And it isn't just Llama models. You have models that are based on sort of like more like less license restricted architectures like GPTJ or MPT. We actually just so this is not released yet, but I guess it'll be released by the time this podcast comes out. Falcon is about to launch very soon. So sort of like the move over the last few months has been, we want to get the least restrictively licensed models in the hands of as many people as possible, because that is the way you ensure that these systems can be deployed safely. So that's what we sort of been building with GPT4All, and the core focus has really been on like software ecosystem stability. The model is amazing. As you can go on Hugging Face, look up the word GGML, and find hundreds of models that exist that are all different versions of like Llama fine-tuned or MPT fine-tuned or GPTJ fine-tuned, and they're all sort of just like they're there. Sometimes it's hard to use because the sort of software ecosystem doesn't support all of them, because there's a lot of breaking changes being introduced in sort of like the core components that make these models run fast on CPU, like GGML or Llama CPP. And sort of what we try to do at GPT4All is make it easy to use for everyone by like eliminating all those like software errors that you might encounter, and also create like sort of the most stable ecosystem all the way down from like the C++ code that's optimized to interact with your L2 and L3 caches of your CPU architectures, all the way up to like the Docker images with HTTP APIs that you can deploy into production. And we try to give it out for free under Apache 2 license. That's sort of like the thesis. Everyone should have access to this technology.
Yeah, I mean, I learned a little bit about this L2, L3 cache, like the optimization for CPU inference with deep learning, from speaking with Michael Goyne at Neural Magic and learning about what Neural Magic is doing to run on CPUs. I think it's really hard to undersell like how impactful that can be running it on the CPU, because it makes it so much cheaper to sample all these inferences, and then you couple that with like the auto GPT strategy of coming up with these action plans, and like, or like GPT team is like another example of like, you have role playing LLMs that communicate with each other, and with CPU inference being so fast, it's also fascinating. But quickly, before maybe if we talk more about the implications of models like this, I want to get a little more into how you train this. So, things like, say, the low rank adaptation, like, because I always, these models typically have come from like Google, OpenAI, Microsoft, right? Like billions of dollar, big. So like, how are you able to,
Yeah,
train this?
I mean, let's be clear here. Like what GPT4All has built stands on the shoulders, like the very broad, gigantic shoulders of open source science, right? Like we put a bunch of ingredients together and spent a bunch of time curating data. Like we used Atlas to curate the data. That was sort of like the edge that we had. We can very quickly take a large collection of data, make it clean, so we can train the model, and that model actually be like useful to interact with. It could feel like Chat GPT, even though it wasn't at the time the quality of Chat GPT. And on most tasks, like sort of tasks that require like reasoning. Creative task was pretty good. So like the ingredients, so like what are the ingredients to make a GPT4All? That's I guess the question you're asking. The ingredients are as follows. Number one, you need a very strong pre-trained model backbone. That is a model, a large transformer model that has been pre-trained on a whole internet worth of data, trillions of words, tokens. You need a model like that. That's very expensive. It costs millions of dollars to train a model like that. Thankfully, Meta did this thing where they released one for researchers to use in an open source fashion, so the research community can build around it. So that happened, and now everyone else is doing this, right? So the UAE released the Falcon model recently. Mosaic released MPT, but the ingredient is a very, very strong backbone, because without a model that knows about language, you can't fine tune a model that can be a chat assistant. The second ingredient that you need is a lot of high quality data of humans interacting with chat models. Now, what we did in March is we found this really nice high quality model that you may have heard of. It's called Chat GPT. And we took a bunch of examples from that model by giving it questions that humans might ask to sample what its responses would be. So we basically went on Hugging Face, got a bunch of data sets of people like prompting models to do difficult tasks like write poems, or like answer a question thoughtfully, or use like chain of thought reasoning to produce out an output. And we sampled those responses. And then we took that big pre-trained backbone, so Llama, and we trained it over top of that data to be able to act like a chat assistant. So a chat assistant has to know when to stop answering, have some idea of like who it is, what it can and can't do. And the way we were able to actually manipulate that data such that you can put it into training is using that tool Atlas we were just talking about. There's many ways you can do it, but the reason Atlas was important is because if you train with data that, for instance, has a lot of duplicates in it, or the data is not diverse, what happens is the model sort of the fine-tuned model that you have sort of falls into modes where it can't actually go in and use useful chat assistants sort of across the board. So Atlas was really sort of important in ensuring the diversity of the data and ensuring the data didn't have any like duplicate examples. Because the second you have duplicate examples, the model starts memorizing what those duplicates are, as opposed to like learning how to generalize over top of like all possible chat interactions the model can have. So that's kind of ingredient number two. Ingredient number three is make the models run fast on every single machine that isn't equipped with the NVIDIA GPU. That's sort of like all the work that came out of like Gergenov's GGML library, which allows you to run ML models quantized really quickly on CPU. So you have like custom matrix multiplication kernels that allow you to execute quantized model inference very quickly. Llama CPP, which sort of gave us sort of like the interface layer on top of that GGML library. And sort of all those ingredients were put together. We curated the data nicely, spent eight hours on a DGX A100 to train the model, and then out of the DGX GPU oven pops out this GPT4All model. Those are the ingredients and recipe if you're taking notes.
Yeah, I got my notes. So let me rapid fire you quick questions on the three things. So firstly, the large pre-trained transformer as the base. You mentioned Llama. We see, Falcon, MPT, GPT-J. There's also, I think, Stability AI. I think they have models. There's like Valkyrie. without like just saying how many
Yeah,
open source
there's a model. There's a pre-trained model zoo emerging. Which one do you pick is a matter of
yeah.
trying out for your use cases. Yeah.
Yeah, so is llama are most of these open source language models we're hearing about are they pre-trained base models, or are they mostly fine-tuned checkpoints from llama, and should
Um,
people be
the only pre-trained base models are Llama, Falcon, MPT, GPTJ, and then probably all the ones that all the closed source AI companies have under the hood and aren't sharing. For instance, like Character AI, OpenAI, Anthropic, they all have their own ones. But those are the core, because again, it's super expensive. It costs millions of dollars to train one of these models, and a lot of data curation work. It takes teams of people to get one of these models out. And every single other model you hear is a fine-tuned version of one of these models. So somebody took a data set and they trained it for a little bit of time, spent like a couple $100 of GPUs to get one of these models out. So that's kind of what you're seeing.
fascinating? So then my second question about the collecting the data. The first question I have is about like, can the language models talk to each other and then you bootstrap the data that way? Is that promising, or do you think you need the human in the loop for it?
Yeah, so I mean, look, you can. The issue is like the overall, like a lot of research papers sort of investigating this issue, like what are the limitations of taking an existing model, and the technical term for this is distillation. You can also call it training on another model's outputs. What are the technical limitations of like just how far can you get, right? Can you get a GPT-4 quality model by taking GPT-4 responses and training against it? That's like an open question. And so there's papers that have been released in the last month that say, no, of course you can't. And then there's papers that say, yes, of course you can. And then there's models out there that sort of conflate with like the results of the first paper. So the question is, can you do this? You can. It gives you better models out than what you'd get if you, for instance, spent a bunch of time curating that data yourself or generating that data yourself. But I guess my hypothesis on your exact question, can you make models talk to each other and generate data? Probably not, right? Because the models will not get the data you collect from that will not be any better than than the initial models that are talking to each other.
Yeah, that's a good point of the model, because you're just sampling it. And I mean, I guess, yeah, I'd love to know what I haven't caught up. I've seen there's a viral paper title that's something that's saying that the knowledge distillation models are just learning to imitate. They don't have the robustness kind of properties of the so I think knowledge distillation is one of those algorithms that seems like on the surface level, it seems like a gold mine for deep learning because you're compressing it. It
Oh,
seems
it is, right. So, like on the technical level, what's happening is that these companies are spending mass amounts of resources to number one pre-train these models. Like sort of like companies like OpenAI and Anthropic are spending mass amounts of resources to pre-train the models, so millions of dollars. Then they spend a couple more $1 million, if not tens of millions of dollars, to gather human feedback of people interacting with their models, and then be able to use this process called, for instance, RLHF, reinforcement learning with human feedback, to tune the models to be more aligned with like what their definition of like a good model is. And that costs a lot of money because you need a bunch of humans to actually be looking at the model responses and saying yes, no, maybe so. And then once you have that, at the end of the day, you still have the same neural network. It's a point in high dimensional parameter space, like R 40 billion, R 175 billion. You have a point there. And when you sample outputs from that point, you might not have to go through the whole process of RLHFing a model. You might not have to go through the whole entire process of, for instance, pre-training a model that's the exact same pre-trained checkpoint that OpenAI or Anthropic started with. Because what you're doing is you're distilling the way that model generates out without having to, for instance, have an RLHF model in the middle. And that's sort of like the promise of distillation, is that you don't have to go through all these intermediate steps to get to, that the company created that original model. You don't have to go through all those same steps to be able to replicate that same sort of point in parameter space, which is the GPT-4 model that everyone is using, because you can just sample its outputs. And distillation has been a thing for a while. Like, I mean, I think the OG distillation paper was like a Hinton in 2015. Like Hugging Face's claim to fame, the way they got so popular was like they have this model called DistillBERT, which is basically a compressed version of BERT, which used like teacher-student distillation, like 2018, 2019. That's like what made Hugging Face pop off. So it's a technique that works well. The question is like, will it achieve you the goal of getting AGI? Probably not, because like you're only going to be as good as the teacher model that you ever distill from. You're not gonna learn anything new. It's my opinion.
But it's really interesting because it's like, will that get you a smarter model? Probably not. But it's like this idea, like I think the Gorilla paper is the latest one, hugging GPT, where the smart model orchestrates inferences to the task specific models, and then it's cheaper to run inference with the, like, I had the distilled BERT had a huge impact to my like career in this as well, where it's like it was just small enough to fit on the GPUs and let you train it. I think it was like 330 million parameters for BERT compared to like 50 million for distilled BERT. So that difference in what it requires to fine tune these models, run inference is like massive. And I love this angle that you're saying with Atlas, with looking at the data deduplication. Something that inspired me a lot as we're thinking about distillation is maybe to see the evolution of two cluster spaces with two models. So like the MNIST example we saw, where you're seeing this evolution of the space, maybe seeing how different models evolve. Have you played around with that kind of idea?
Yeah. So the one place we've used Atlas or internally at Nomic in the loop as so we have the software ecosystem for GPT4All. We also push our own models out, which we spend a lot of time curating, sort of getting the best models that are good with the bread and butter tasks LLMs need. So we do a lot of internal work of just like training the models, making sure they're good. And we use Atlas heavily to making sure, number one, like the data that's going into them is good, but also while the models are training, figuring out what's going wrong with the fine-tuning process. For example, the GPT-J model, which was sort of like the first Apache 2 license model that we put out there, the issue we were hitting with that model is, so it's a much smaller model than what you'd get with like a Llama 13 billion or a Llama 7 billion. It's smaller in the parameter count. It's also smaller in the amount of like tokens that it's seen during pre-training. It's harder to train. And what we were hitting was this fact that while we were fine-tuning on the exact same data set we were pre-tuning Llama on, the model was just overfit. Like at a given point, it would just complete, like the training loss would just like plummet down, eval loss would spike. And what was happening there, and we were so confused, like why is this happening?
Mm-hmm.
It works perfectly on this like other model. What we were able to do is actually take every single point that we were evaluating the model, rather every single point that we were training the model on, and take a checkpoint of the model right after it started overfitting during training, and visualize sort of like the loss. So we had on Atlas mapped out the scalar loss. So all the examples where it had high loss, all the examples that it had low loss. And there was this region of the embedding space, which was just like all red, which was like all corresponded to the region with super, super low loss right before the model started overfitting. And this region was on creative examples. So we had all these examples of the model doing the tasks like summarization, like finding named entities in text. But there was this one region where we were asking the model to like write creative poems. And the thing with creative tasks is what happens is you have the exact same question, and you might have many, many different responses to that question that are all valid responses. And what was happening is the model started overfitting to that region of the space, causing an entire collapse in the model's ability to do anything else on other types of examples. And the way we immediately realized that this was the issue is just so we looked at the Atlas map and was like, hey, look at this big bright red spot. What's in there? Holy crap, like creative examples that gave us that hypothesis. We downsampled them, and then the next model trained, boom, the model was great. GPT4All J was deployed.
Wow, that's such a compelling story. I mean, I've seen things like working with class imbalance, where you have one label's 90%, the other's 10%, and so it's always going to predict the 90% label. So you do like random oversampling, where you balance it out by sampling. And I remember like back in the days of training GANs, you have the mode collapse, where it's like just generating this deer that's like the middle of some region of deers. Yeah, all that's so interesting. So kind of coming out a little bit of the technical details of training this, I really want to ask about the GUI that you've built around GPT4All, how you're thinking about things like the ChatGPT marketplace and like how those kind of apps into the UI fit.
Sure. Yeah. I mean, I think long term, the viability of selling outputs of large language models goes to zero. I mean, you've just seen it in the past 2 or 3 months. There are amazing models coming out that anyone can run on their own hardware. So what we've really tried to do with the GPT4All is sort of focus on getting a very stable software ecosystem that adheres to all the users of LLMs. And users of LLMs are not just developers; they're everyday humans who want to, for instance, like put in their local data or like their local PDFs and just ask some questions about them, right? So the GUI that you see, if you go to GPT4All.io, you can download a Mac installer, Windows installer, Linux installer. What that is it's a chat application. It's written actually it's C++ framework called Qt. Qt also runs like sort of the monitors of like Mercedes-Benz's or like Adobe Photoshop is built in Qt.
Cool.
And what it's doing under the hood is it's talking with our C++ libraries that have, for instance, Llama C++ baked in, all the versions of GGML baked in, all the various sort of ways you need to define the weights of the machine learning models for the different transformer architectures, GPTJ, Falcon, MPT, all that sort of like under the hood. And all you see is sort of this chat client that you get that you'd go, for instance, when you see like you go to chat.openai.com. And the reason you need sort of this client is like for local LLMs, there are sort of a few caveats that you need to do a lot of software engineering work around to make them as usable as you would see, for instance, a model where you're just like interacting it over like WebSockets or HTTP calls, like you'd have with like Anthropic or OpenAI. And that is like, for instance, when the models all run on CPU, right? These models are large. They take up like 4 to 8 gigabytes of RAM on your machine. And what happens is what you need to do is you need to be able to cache the model's internal states if you want to very clearly say resume a chat once you've stopped it. There's like all these sort of like nitpicky things that are actually pretty hard to implement if you don't have a bunch of elite hackers writing the code to manage it. So, and that's sort of what we've done. Everything from the C++ code. If you go to the GPT4All GitHub repository, it's all Apache 2. You can go in, rip it, use it for your commercial purposes. Don't use Llama. Use the Apache 2 models. You use it for your commercial purposes. Like you're happy. Like we're happy to we want to maintain the most stable software ecosystem around these models. That's the intention.
Yeah, I think you're quite an entrepreneur. I think you have two incredibly compelling businesses here with Nomic and then also this local ChatGPT marketplace. Like this first thing of porting tools to work locally. That's so fascinating. I've seen like Microsoft semantic kernel kind of, to me, looks like maybe like a ChatGPT marketplace LangChain that's designed for a specific set of tools, like the Microsoft tools.
Yep.
Can you tell me more about, not making the HTTP requests, keeping the integration of tools privately?
I mean, sure, right? Like, have you called NVIDIA in the last couple months? They're not going to answer your phone. They're doing great. The reason they're not going to answer your phone is because if you go to an order, let's say like an H100, be like, hey, NVIDIA, get me an H100. They're going to talk to you, and if you're not on their like list of like top 10 customers, you'll probably not get a response. And then if you do, what happens is tell you, amazing, here's your H100. Send us the money. We'll send you the card in about a year. 48 weeks is the time to get a GPU right now from NVIDIA for like these server grade GPUs that can run these like large language models. Everyone has been ignoring this massive ecosystem that we've built of just like machines that have CPUs on them. And there's a couple of difficult engineering challenges to make these models work on these machines. But if you can leverage that, every single let's say CPU enabled machine that you have on AWS, that you have on Azure, that you have laying in your garage on the ground, those can run large language models on them. You don't have to sideload all. You don't have to run all your. The whole reason you have to run machine learning models in like behind APIs is because you have to run them on GPUs. Not everyone has access to them. So, yeah, that's the thesis. Like models can run on CPU. We can demonstrate it. Like here, go play with them in the chat client, and like, hey, go build your software over top of it as well. You can own your LLMs. There's another big thing happening in this area right now. I just want to call out Apple. I know everyone's like freaking out about their headsets right now. I'm freaking out about the fact that they've put in basically like GPUs onto every single device in the world and just like aren't using them right now. Apple Silicon that is plugged into your like M1 or M2 Mac. I think the M2s have like sort of the best GPUs right now. You'll be seeing in about a week's time, you can run a local LLM at like 40 tokens per second, which is like the speed that you get out of like a Chat GPT model when you go to the web UI, all on your machine just by having a Mac. And like iPhones have these chips, all these other devices have these chips in them. You will be able to run gigantic useful LLMs all in your devices in like the next few months. It's real.
Yeah, the Apple thing is certainly like game changing, something that's emerging. Colin Harmon on a last podcast, it's not published as we're speaking, but had mentioned this idea of the language models come on the chips in Apple devices, and I thought that was really compelling. I read that paper on Byte. It's like Byte's transformer, where they're taking bytes directly as input to unify modalities. A lot of interesting ideas coming out of Apple for sure. Maybe quickly, I wanted to comment on this idea of like running models on CPUs. And I also kind of wanted to bring back to the Weaviate topic and talk about running big vector indexes on CPUs at Weaviate. And so something that we're researching that I think is incredibly compelling is developing the disk ANN vector index. So the disk ANN vector index is about optimizations to move some of the vectors to disk compared to having to keep the whole graph in RAM. And so this way you could just, on your laptop have like an 100 million vector index. And I'm sure you have some ideas about like how you do like 10 million scale visualizations in the browser and this kind of thing of like, not only are we making it easier to, run inference cheaply, we're also making it so you can visualize embeddings of just and visualize, and then also the database side do the nearest neighbor searches at absolutely enormous scale. What do you think would be kind of the implications of that idea?
I mean, compute must be moved on the edge. Like there's just not enough server hardware. Like it's a fact. The more things you can do on edge devices, the more sort of offloading you can do, the clever you can be about how like we're in the very early days of ML. A lot of the stuff people are using are just been written by researchers who cared more about making the systems work as opposed to optimizing the systems for like actual utility in like let's say like in production or just like actual utility to everyday humans. I think there's like amazing work happening on that end. Like we're trying to keep up as fast as possible. Like we can ship tens of millions of things to your web browser and run it on your 8 GB Mac. What you guys are doing on the disk ANN side, like that's amazing. Like please show me, and I will hack with it because like that's great. The better you can utilize resources on the hardware that already exists, like the better it is for everyone involved.
Yeah, and one of the topics that like when people ask me like what is exciting you the most about AI right now is this marriage of say GPT4All, cheap inference, and then the vector embeddings at scale with DiskANN, et cetera, and Atlas for visualizing it. Is like we can have the language models like talk to each other. We call this generative feedback loops, and like we've written a blog about this concept of like the language models, they produce all this data, and now you need to like tame the data. So it's like you need to produce the latent space, but like, it's like, let's say it's an image generation model. You sample it's like a billion images from it. And now you need to like look through it and say like, okay, what is it created kind of, right?
Yeah. Yeah, I mean, I think it's going to be a gigantic issue right now. Like, if you thought the 2016 U.S. election was scary because social media was in full swing, you're going to be frightened by what happens in the generative AI election that comes up in the next few years. Every single like it is the marginal cost of generating convincing content that's ultra personalized to anyone in the world is zero right now. It is already zero. You are when you go on Twitter, you're probably interacting with LLMs and you don't know it. You go on Facebook, you're probably interacting with LLMs and you don't know it. And they're personalized to you. They know about you. They've been prompted with like your bio. And this is a gigantic issue. When the whole internet's going to be flooded, like it's a gigantic issue for ML model training because like how do you train on an internet that's flooded with ML generated text? It's a giant issue for like everyday people who are like don't even know these systems exist. Like ChatGPT has only been used by like 5% of the U.S. population or something like this. Maybe that's a wrong metric, but I saw this recently. Like most people haven't been exposed to this technology yet, but they're being exposed to the outcomes of the technology. The internet's being flooded with the outcomes, the outputs of this. This is like actually one of the theses about what we were started building out at Nomic is like if the whole internet's going to be flooded with generative AI outputs, be that images or text, you need some way of digging through it. You need some way to have observability over top of it. An Atlas map is that observable interface, I believe.
Yeah, I think so as well. I mean, having the visual component to pair with what we're building on just hosting it, it's a peanut butter and jelly type of pairing with the GPT4All, this trends in cheap inference. Yeah, wow. I mean, kind of staying on that personalized generation thing and sort of like the next generation of spam where it's like, hey, Connor, I read your blog post about this. I have these thoughts. And it's like not even a person on the other end. It's like, I remember like one of the big AI things was like Ian Goodfellow is like, he's going to work at Apple. And he did this interview with Lex Fridman where he talked about how important it's going to be to have like cryptographic signatures that come out of the iPhone pictures to say like, this is a real picture. Do you think a lot about that kind of thing? And like, sort of how that will change the world?
Yeah. So one thing we did with the original GPT4All model, I've never actually told anyone this, so I guess you'll be the first to know. Is we watermarked it. We put in like a into the training data. We put in like this phrase. Which the model trained on, and it's actually in the maps. If you can find it if you search for it. It was basically this ID, and then we could know anytime a system is using GPT4All by putting that like string, and it'll generate out something that we know is it could only been generated out if they were using the model. So like we have thought about this a little bit. and we're not doing anything with it. Like it turned out to be like a sort of a useless thing to do because actually it didn't work quite well. But it was a thought that we had. But yeah, this idea of just like how do you control for like how do you determine if something is made by a human or not made by a human in a manner that doesn't require like going through like some centralized entity to mediate that. I think it's a giant unsolved question right now. I mean, I think like I believe this is like the thesis of like WorldCoin, right? Or like what Sam Altman is trying to do is like scan everyone's irises, and then when you tweet something, you can call their API and verify whether or not you're actually tweeting as a human, or you're take a forward facing picture of your camera. I think that's where that whole thing's going. I mean, it's an insane problem. I'm sure every dictator in the world right now is ultra excited because they just decreased like their like troll farm costs by 8 million% to like one developer.
Yeah, I mean, I think it's great. And the topic I wanted to kind of anchor this podcast with is your original PhD interest in interpretability and machine learning. I think it's related to this topic of like, I think this topic is like, can we detect content generated by these models, which has a lot of nuance to it, and then generally maybe interpretability. What initially drew your interest to that research category?
Yeah, so I guess you put a statement in there. I want to be very clear in my opinion of it. You cannot systematically detect generated content without having some extra metadata attached to it that by the provider where that content was generated in. It is an intractable problem to be able to say, here's a piece of text. Was this generated by like a machine learning model, not generated by a machine learning model? That's a fact. The sort of like meta level question is like, why did I get into like, I was just really interested in my whole life, and just like I wanted to understand how systems work, and ML was like the coolest thing to work on. And I guess very naturally, like I joined like the deep learning world like very, very late. This is like 2018. This is like after like all the fun stuff had been done and everyone was realizing that like data was the actual juice that powers these models. And like after the transformer model came out, you see every single ML system that's being built right now is being built with a transformer. The model is staying the same. The training objectives are staying the same. The regularization methods are staying the same. It's all just different cocktails of data. And the realization is like you need better interpretability methods to be able to actually like these models will be the differentiating factor between all ML models being deployed will not be usually architectures. It'll be the actual data that they're trained on. You need better interpretability methods to understand like the data going in, the data coming out. And that's sort of kind of what spiked my interest sort of originally. I had realized like I spent a bunch of time in my undergrad working on NLP for clinical domain data. So like working with like medical notes, and that was just all like a data problem. It's just like the methods were fixed. You just copied the methods that were the general NLP community was working on, and you had to get it working on the data that you had. So I just had a lot of experience sort of digging with data that was non-standard, I guess, and I saw the problems.
Yeah, that's really, and I'd say with the first thing I'd say with the first thing, I think with like the style GAN, I remember studying like the watermark artifacts that maybe with images generated, there's something to the patterns that can help you detect it. But with text, I agree. It sounds like there's no hope with that.
Well, even with images, right? So if a malicious enough actor is like, I want to generate things that are undetectable, and then you go out and you make your detector. Amazing, you made your detector. Now they can use your detector to improve their generator, and then like it's a race to the bottom. And you see this like it's like like there's like the story of that college professor who got failed his students because he put in data into Chat GPT and was like, hey, is this real or not? He actually didn't even use their detector. He actually asked the model itself, which is a different problem with these models and people using them. It's a UI problem. But it's impossible to say whether a string was generated or not by a model like going forward. We have to think of other methods of ensuring that these systems are being sort of like safely utilized in the world outside of saying like yes or no to whether or not this was machine generated. That's not a valid solution.
Yeah, I think that's fair for sure. I think maybe I was thinking maybe there's something with like adversarial. No, like how you see like it's like harnessing adversarial examples. The classic example where it's like a panda and you add the adversarial map to it, and now it's like given to show that like these patterns are like so fine grained, kind of like if you're talking about like a 512 by 512, 255 in each pixel RGB, it's like maybe there is some pattern that's detectable. But yeah, I agree.
Yeah, I mean, like, yeah, if you take a model off the shelf that some researchers have produced, like, yeah, you'll be able to, detect whether or not a sample is in the distribution of that model or not. If you have a company that really cares about the quality of their models, like, like, if to be a little bit forward looking here, I think what'll happen is just like likely the outputs of machine learning models that most people interact with will be coming from a few large companies that have these models that are managed and they're producing these models, and they're going to develop their internal methods for tracking whether or not somebody is using their models outputs in some way that they don't like or doesn't abide by their like ethical or moral standards. The bigger problem is not that. The bigger problem is like when access to these models becomes democratized, you have to build tooling that can fight that being happened by malicious players. And that's like kind of like a lot of people have asked me like, don't you think it's unsafe to be giving these LLMs to everyone? Like, shouldn't they be stay behind like closed doors because that's how people can control them? My sort of refutation to that is like, if you keep it behind closed doors, what happens is great. You've centralized the ability of any actor in the future to be able to say whether or not somebody can use the models. B, somebody they can, and B, they can go in and say, has a model output been generated by us or has not been generated by us, and sort of change how people interact with data based off of that. I think by giving the models out to everyone, it allows everyone to actually see like what is the actual current state of the art and what models can do, and sort of build the appropriate countermeasures for it. That's sort of like my refutation there. I get asked about for a lot.
Yeah, that's certainly one of the big topics emerging. I mean, I think that's a great argument in favor of the open models, and I think definitely you're one of the big voices for open with models with GPT4All and being behind that and all. Yeah, I don't have too much of an opinion on it myself, other than just seeing the conversation forming around it. Like Sam Altman, obviously going to U.S. Congress, made a lot of noise about regulate and yeah, I remember, yeah, there's also like the topic of like the toxic language models. You train it on like that kind of data and produce that kind of stuff. But yeah, it's really interesting topic. And I also, something that you said about the data centric focus on AI coming out of that, like the data centric focus. I also agree heavily that it seems like data centric is the way going forward. Like it's not like neural architecture tuning. Like I don't think the variance in the transformers, well, actually, well, because I do think like flash attention, these kinds of things are how they're like scaling the input length. So it's certainly impactful, but I think that the data centric is definitely the number one thing to focus on.
Yeah. Again, that's what I spend all my days sort of thinking about and focusing on. It's how do we make sure that when we have hundreds of millions of documents of text or images or embeddings being produced out, how do we make manipulation of that easy? There's a lot of ways to do it, right? Atlas isn't the only way to manipulate large quantities of text. I hope it's going to be the easiest way that allows people who are increasingly non-technical to be able to do it. That's why we're building it. That's the premise.
Yeah, awesome, Andriy. Well, I think Nomic and Weaviate, these two technologies pair together so nicely, and you have so many interesting ideas. You built so many interesting things. So thank you so much for your time on the podcast. Before we wrap up quickly, do you have any announcements about upcoming projects or how people can, hopefully mesmerized by all your knowledge, can keep up with your future work?
Yeah, I guess follow Nomic_AI on Twitter. We're constantly putting out amazing content about sort of democratizing access to the data and models that surround sort of the current AI systems. I guess the biggest thing to look out for very soon is you can run big LLMs on your computer, and if you have an M2 Mac, you'll be able to run it at the same speeds of like a ChatGPT model that you see, and that's going to be released in the next sort of week or two. So go try out local LLMs because you don't have to send all your data to third-party services just to access this technology.
Amazing. Andriy, thank you so much.
Thank you, Connor.